All right. Well, it is 4 o'clock on the nose, so I think we can get started. I disabled the waiting room, so if we have any stragglers, that's totally fine. Everybody can just settle in as they enter the Zoom room. I'm Sadie Everett, and I'm the director of the Regional Autism Advisory Council, which is part of the IDD Ed Center at the University of Cincinnati. And what RAAC does is provides opportunities to connect, network, collaborate. I also provide help facilitate and provide um, professional development, training events like today, training series like this series as well, and just really tapping into what the community needs and trying to deliver on that. So I have partnered with Lori Foote and Rachel Evans here, and I'm going to let them introduce themselves, and we'll get started with this awesome training.
Well, hello everyone. We're actually going to introduce ourselves in just a second. So if that's okay, Rachel, I'm going to have you do that as part of that, and I will as well. I wanted to welcome everybody to what I hope will be an exciting three-part series. We're excited to be working with and partnering with our friends at the
Make
RAAC,
it big.
Regional Autism Advisory Council.
Probably.
Um, this is going to be focused on math, which when I have talked to all of my intervention specialist friends, they tend to lean towards English language arts. So I'm hoping that this is something that you'll find interesting and hopefully, we can get some really good discussion around the idea of math and algebraic thinking. So, the goal for today is to talk about algebraic thinking, and specifically, we're going to talk about math representations and connecting different levels of math thinking. And then I've sort of got in cursive there a subtitle of leveraging high quality math instruction to support the needs of students with autism, because we are sort of taking this from a platform where we've been working at the ALLOhio site for all intervention specialists. And we've really tried to think a little bit more strategically about how this might, in particular, be helpful for helping instructors, whether you're the special education teacher, the general education teacher, paraprofessional, any of those types of people that you might be able to support your students with autism in particular. They're listed there. You'll see the other two sessions that are coming up. So we'll have a little bit different focus, but all of that is going to be working on algebraic thinking. And I did want to mention that the partnering agency with RAAC is the All-Ohio Literacy and Learning Science, which is part of the University of Cincinnati. They have been working with the state of Ohio and a few other grant funders to provide a lot of resources to educators, special education, um, uh, in many varieties of modules, including English language arts, science, universal design for learning. These are all free resources for teachers. So I'll talk a little bit more about that at the end, but I did want to mention that up front. So now, yay, we're finally ready to get into some introductions. So I'm going to just call on folks. I hope that doesn't feel uncomfortable, but I'm going to go ahead and just call on people in the order that people are listed on my screen. And I've got a little prompt there. Just tell me a little bit about yourself. So tell me your name, tell me if you're working in a school or where, what you're affiliated with. And then just tell me a little bit about your context. A lot of times special education looks different in different places. So if you could tell a little bit about your, how that operates in your school. And then, kind of what brings you to today's session. What is there something of interest that you would like to learn about? So I'm going to go ahead and start with Sadie, let you be the warm up.
Great. Well, I am Sadie Everett, and like I said, I am the director of the Regional Autism Advisory Council. Um, I am really, I'm again trying to tap into the needs of the community, and the SDI Center and the All Ohio Literacy Group, they do amazing things, and they have training modules that are free for teachers and just amazing, amazing resources. So when I learned about this, I was like, let me try to help push it out and just get these tools and resources in more hands. So that's why I'm here today.
Great, so much. Rebecca, do you mind going second?
Yeah, no worries. I'm Rebecca Wilbrand. I work at Cincinnati Christian Schools as a intervention specialist with my focus being on our third grade students. Um, so I do a lot of push in and pull out, and I have a lot of students who need, most of my students need language arts, but there's a handful of them who need the math aspect too. So I thought this training would be good to get into some of those math strategies and ways to benefit those students.
Thank you. Welcome very much. Thank you very much for coming. Kevin, can I have you introduce yourself?
Certainly. Can you hear me?
Yes.
My name is Kevin Bieneman. I currently work at the Height Center for Excellence in Cincinnati, Ohio. I serve as the math teacher for uh, 9, 10, 11, and 12 uh, grades. And I have previous intervention specialist workings in elementary school as well as high school. So I'm kind of like nearing the end of my career, I guess. It's many years, and so I'm teaching math and loving it. And my kids are definitely enjoying math, and I want to learn more so that I can be a better resource for my students.
Can I follow up, Kevin? It sounds a little bit like you may have a long career, but maybe are newer to math. Is that correct?
Yes, my master's degree is in intervention. I did not get a college degree in math, nor do I have a teaching degree in math. In fact, math was not my best subject in college. Of course, I made it through high school and everything, but it's just refreshing to learn more and different styles and different things that the kids have grown up with, and I'm in a great position to maybe just take math a little bit more slowly so that everything sinks in, and that's been a really great place for me at the school.
Good. All right. Thank you and welcome.
Thank you.
Tracy, can I have you go next?
Hi, my name is Tracy. I actually am the interim eligibility manager at Metro in Cincinnati. The reason why I wanted to join this call is because some of the people that I will be working with have autism, and I want to learn different methods in order to be able to better assist them.
Okay. Can you tell me a little bit more about your position in terms, I'm not familiar with what that is. When
So,
you,
have you ever heard of Access
Mhm.
Paratransit? Yeah, so I do the assessments for them, but I
Oh,
also
yeah.
was their travel trainer.
Mm.
So either way, this will be information that will be beneficial to me.
Okay. All right. Well, welcome. Thank you so much.
Thank you for
I'll
having
let,
me.
oh, sure. Michael?
Hi, I'm Michael Kennedy. I work at Linden Grove School in the middle school building, 6 to 8 team. I used to teach math, science, and now I'm curriculum coordinator for math, science, and STEAM, and still teaching robotics and coding.
Oh,
And I've been teaching, this is my 31st year. Still like to gain more math strategies and everything that I can take to my fellow teachers and help them from grades K through 8 in our building with our autistic population.
okay. Thank you so much. Welcome.
Thanks.
Sydney?
Hi, I'm Sydney Fullerton. I work at the Height Center of Excellence with Kevin, actually. I am in the middle school classroom, teaching sixth through eighth, but academic levels about kindergarten through eighth grade.
Okay.
And at Height, we kind of serve as both the intervention specialists and the general educators. So I'm the math and science teacher for middle school at Height.
Right. All right, great. It's great to hear that you guys are sounds like you're sort of a team.
No, so he teaches, Kevin is the high schoolers and
High
I'm the
school.
middle school.
Got it. Got it. You pass your kids off to him.
Yes.
Thank you. Welcome. Kira?
Hi, my name is Kira Kamara. I'm an intervention specialist at Data Montessori here in Cincinnati Public Schools. And so I service students that are first, second, and third graders. And just like all schools, we have a range of students on the autism spectrum. And so I am always looking for new strategies to work with them in this content area. But more specifically, as a Montessori school, I am looking for things that can be very concrete and hands on, and our students love to use manipulatives and touch and understand math. And that's kind of the way that we teach. So I'm always looking for ways to do that from an intervention perspective.
Okay, great. Thank you so much. Welcome for to our session tonight. And Rachel, I think, is that the last person? I don't want to cut anybody out, but I'm struggling. I've got the across my screen here. I think I got
I think I'm
everybody.
the last person, yeah.
Okay. All right. Rachel's next.
Hi everyone, I'm Rachel Evans. I'm also with the UC SDI Center, so I work on the BRIC project along with Lori. I'm very happy to be here. Anything to do to support educators in learning math, practicing math. So I'm looking forward to today and happy to see you all.
Thanks. And I'm glad to see you too. My name is Lori, Lori Foote, and I'm a faculty member at the University of Cincinnati. I'm teaching research methods, and I also, this semester, I'm teaching middle school math methods. I've taught elementary and middle school math methods for the last probably 5 to 7 years. And before that, my previous life, I was an elementary teacher, so I taught 3, 4, and 5 for almost 20 years. I went back to school and my kids went to college. We all went together. So the interesting thing about where I was at, I taught third grade for most of the time I was teaching, and we were we were partnered up. So I taught 2 groups per day, and I always volunteered to work with the students that were on IEPs, and they actually put students that were, also struggling in math in that classroom. So over the years, I worked with intervention specialists a lot. I did have a few students that were diagnosed as being on the autism spectrum. I feel like it became more after I left. So I just say that because I am not an autism specialist. And I think part of the conversation I'm really interested in having with all of you today is, as I'm thinking about my experiences working with a variety of students with special education needs, and just, students who were not identified but still struggled. Um, I felt like I leaned into a lot of tactics that were helpful in math, and as I got my doctorate, I studied a lot of the research that was out there around high quality math instruction. So I'm really looking for, you guys to really process through with me. I'm coming from the math perspective, but you all are coming from your, various levels of, different types of expertise that you're bringing into this space. So I really want this to be, I'll share some of the math things, but I really want this to be a discussion. And so I want you, at any time that you kind of think of something, to feel free to drop something in the chat. And then so often we're going to pause and have time to just chat. I don't think we're a big enough group that we'll probably break into breakout rooms, but I do want us to have those type of breakout room conversations at a couple different points during the session. So with that said, I'm going to just sort of talk a little bit more about what we're talking about tonight. So the three-part series is going to be all about algebraic thinking. And tonight we're focusing on math representations, and we'll talk about what that means. But as you can see on the screen there, I've got a couple of arrows next to the subtitle and next to algebraic thinking. And I want to just pause for a second and talk about those two items and unpack them a bit. So the modules that are on the ALLOhio website, we've got an ALG 1, 2, and 3. Those do not stand for Algebra 1. They were just sort of the sequence that we were thinking about as we were sort of backing up and thinking about the types of skills students need to be successful as they get closer to Algebra 1. So it sort of goes in order in terms of, kind of operating from that upper elementary level into middle school, and just before Algebra 1. So algebraic thinking is part of the Ohio standards. You can see on the screen there's 4 or 5 different colors that are represented. Those are the major domains of math. And we're going to be focusing in on that one that says operations and algebraic thinking. And kind of along with that, you can't really do it without talking a little bit about operations and base 10 and just what numbers mean, because, as the students are continuing over time to build those operational skills and understanding, how a word problem translates into an equation and how they can represent things with numbers. They're also developing their number sense. So that all kind of comes together. So we're going to focus on that part of the Ohio standards. But as I think about algebraic thinking, and as you kind of could see from that past diagram, algebraic thinking is something that the students are starting in kindergarten, and they're really, I've got on there K through 5, but it's really continuing all the way up into algebra. So it's that idea that math has rules and there's properties and there's things you're allowed to do and things you're not allowed to do, and sort of moving past one single problem that's in front of you and starting to think about, how can I solve this type of problem? Or how can I manipulate these numbers so that I can solve the problem? It also kind of talks to the idea of hypothesizing about what might work and what might not work and how to test it out. And so those are all, quite high level thinking skills. And yes, eventually we get to those little equations that have letters in them, which is what everybody thinks of when they think of algebra. But as I came into today's session, I sort of had this big question that I started pondering. And that was, how can we leverage what we already know about high quality math teaching and learning in order to maximize our students' development? And when I think about development, I could think about math, but I actually want to expand that to all areas. So, in other words, how can I think about what the high quality math instruction is and have that support students' math learning needs, but also support their other needs that we know that students with autism are going to be bringing into an academic setting? Because if there's one thing I remember so much was the intervention specialists in my school were running themselves ragged. They were running around like crazy trying to meet all the students' needs. And so at some point, you just really want to get the big bang for your buck. If you can get 2 or 3 things out of one thing that you do, you're really doing well. So that's kind of what I'm pondering tonight, and I'm hoping you'll be willing to ponder that along with me. So, as I mentioned, I'm not a specialist in autism, so I did do a little research, and I went back and just sort of formalized what I already, had experienced with some of my students and what I know just from being a general person in the world. Autism is a neurodevelopmental disability that is characterized by differences in communication and social interactions and repetitive behaviors and some restriction of interests. But most students with autism are also spending a good amount of their day in the general education classroom. And so, as I was reading through the different materials that happened to come from Iris, the Iris Center just put out a new set of modules that are on autism, and they had some really current, it was a 2026 module. I wanted to pause and just put it out to you guys. What kind of things do you experience when you're working with your students that we should probably kind of keep in our minds as we're thinking about how we can use math to support a variety of students' needs? So I'm going to pause and let you guys think about that. And if you'd like to pop off your, you know, take yourself off mute and talk, that would be great with me.
I can share something.
Sure.
So I would say like a lot of times with my students, something that I notice is just like a very quick shutdown is like if right away they think what we're doing is going to be hard, it's like they're not going to try. It's a very quick shutdown for some of my students. So just more of like slowly getting into something is a lot more helpful, but sometimes it's hard because algebra is hard. So it's like we have to do this. It's not going to look fun, but a lot of times it's just trying to figure out those things, how to slowly engage into something, just so that shutdown doesn't happen.
Thanks for sharing. Anybody else?
I enjoy that math is kind of the lead dog in this for a change, if you will. There are so many structured ideas and guidelines that math offers. My problem with some of the kids that I have the opportunity and blessing to teach are that previous teaching has gone too fast. And an assumption has been made that they really understand how math works without actually assessing their ability to make that happen. And so I feel like if I can provide a really strong math presentation following everything they need to know about a certain subject, they'll begin to organize their thoughts and realizing that there are certain things they need to have in order to be successful. And so in that, there's a direct correlation then between math and all the other disciplines because there are certain sets of facts that we must begin with. And for some kids, it's a constant reminder of those facts. And other kids know the facts extremely well and want to move even more quickly. So, in finding that happy medium and collaborating with other teachers, it's a great way of showing what works in math. Because the beautiful thing about math and our kids on the autism spectrum is that there is no gray area. Kind of like math, 1 + 1 will never equal 3. As hard as we might want it to be, it will never work that way. And in the same way, sometimes nouns and verbs just happen to go together. And so if we show them that things are connected, then we'll have a better opportunity for their success in all of their content areas, including math.
Makes me think of back in the olden days when we used to do thematic units, and people would try and intentionally bring all the subjects together and
Yes.
connect ideas.
Perhaps I'm showing my age.
Me too.
Yeah. To kind of piggyback on what Kevin and Sydney said, I've experienced kind of like an outburst when you sit there and have math and you talk about algebra with letters and numbers in the same one. It just blows their mind. And so I sit there and look at them and go, okay, so what's mind blowing about this? And relate it to something I know. You guys like ice cream? They're like, yeah. I'm like, so you eat plain vanilla ice cream all the time? They're like, no. Like you put sprinkles on it, chocolate sauce, put chocolate chips, cookies and cream, all these other things in it. Well, that's what kind of algebra does, is they mix things together and they mix them in different rates and quantities and everything. So then, it's like, so now we kind of got the relationship of ice cream to what you're doing in math. So that kind of gets them off, that kind of totem pole of, well, this is difficult. I don't understand. And you got Mr. Kennedy over here talking about math and ice cream. So giving them that relation factor, just kind of like it hits them in a different way instead of going, hey, this is easy. You'll get this in a second. It'll be okay. It's like now you've got this little kind of hook that you can always refer back to, and it just helps spread that kind of discontent out a little bit because as you go through algebra, there's going to be many other hurdles that you'll have to go over. So you can keep bringing that back to that ice cream kind of hook that kind of helped me at least relate math a little bit easier to them.
Okay. Nice. Anybody else? So as I'm looking at the screen and I'm thinking about what has just been said, I'm hearing things like, or kind of thinking about, what will students need if these are areas of differences? So we want to make sure that our students have chances to communicate, to have interactions, probably both with adults and with peers. I was watching that Iris module, and there was a young lady who had autism who was talking about how she just had never had one friend her entire career in school. And I thought, oh my gosh, that is just awful to think of. Like I have grandkids, and thinking about my grandkids not ever having a friend would make me just be crushed. So having that opportunity to have those social interactions and build relationships, we can take advantage of, students' needs. I'm hearing this idea around structure and repetition, and also that we can bring their interests in. It might be talking about ice cream, it might be talking about other subjects. And then also really, facing the fact that a lot of students are experiencing math anxiety before they even know if they can do it, because for some reason they're convinced they can't, even before they start. And so even having to start breaking that down at the beginning. So those are the things I'm kind of having in my mind as I'm thinking about, how can we really focus on doing the math stuff, but in a way that it helps with these bigger goals? And I think, several of you have talked about that as well. Just the idea that, um, everything's connected. And so if we can get them to do math well, one thing builds success in other places, but also it's all connected. And so if you can do this, then that helps you do this later. So let's talk just a few minutes about what it means to do high quality math instruction if we're talking about representations. And this is going to be really based on some research, and hopefully this won't be too boring. So you perhaps have heard about the CSA model. The concrete, semi-concrete, and abstract levels of representations. Semi-concrete, I prefer to call pictorial because it's easier to say, but the CSA is based on, semi-concrete. And it's the idea that we definitely want students to get up to that abstract level, because there's certain things you do better when you get to the abstract level, like manipulate equations and things like that. But before we get them to the abstract level, and only the abstract level, they're going to need to have a lot of experiences in those concrete and pictorial levels. So concrete representations are those where they're able to touch and manipulate the items. The more flexible they are in terms of being able to be relocated and moved around and grouped and things like that, the more likely they are to be concrete. Pictorial is really important because, when you are reading a book or you're looking at something on the internet, they're relying on pictorial because it's a 2D medium. We also want students to be able to take their concrete models and translate that into what you might call like a representation that they can keep on their paper to show what they're thinking, um, a working record basically. And so from there, we can often like sort of map the abstract equation directly onto that picture representation. So you can kind of see that the concrete builds to the pictorial, builds to the abstract, and they don't necessarily need to be kept separate. but we just need to be aware that, when students are not being successful in one of the upper levels, that we may want to go back to that concrete level and have some more experiences to make sure that they're ready for that next level up or to tie those together. I apologize. I'm going to put this screen over here. I'll be looking at you a little bit sideways. I have 3 screens, so if you see the side of my head, it's not that I'm not looking at you. I'm just looking at a different screen. So we don't want them to get stuck at concrete because it's not as robust of a level as we're going to need when we get up into algebra. The other thing I really have been thinking about, I'm teaching my middle school math methods, is this idea of connecting all that we know about math, and some of you really touched on that topic. So you'll see that we've got, using materials and drawing a picture or a model and writing things out abstractly in this list. But there's other ways that we actually represent math as well. So when we put it into a real life problem, especially if it's a problem that they're super interested in. Maybe it's something that comes up in their own lives and they want to find the answer to it, and you can support them through that. Having students be able to talk about or write about their explanation for why they do certain things and the decision points, that I could do this or I could do this, but I think this is the right way to go, and let's do that and explore it. And then, just if that way doesn't work out, we want to be able to have those kids come around and be strategic and try their other idea. And then also we've got things like number lines and graphs and all kinds of other representations that tend to be picture-based, but we can actually make those concrete as well. So we're going to be thinking really about a wide range of ways of representing math. And so, when we think about the different materials and media we might use, there's lots of snapping cubes and place value blocks that are already pre-grouped, and we've got number lines where we can jump on them or we can show fractions. We can use, with the younger kids, we might use the 10 frames or equal groups when we're showing multiplication. We might show arrays on a grid paper, or we might actually build that out with some color tiles. So there's lots of different ways that we can represent, which starts to mix that concrete and the pictorial level. But the idea that we don't want them to just use one, but we want them to be able to translate from one type of representation to another. So for example, you can see that most of the images that are on the screen there are taking advantage of either a concrete and an abstract equation, or they're taking advantage of a picture with the abstract on top of it. Obviously, for our purposes today, these are all pictures, but you could imagine that the snap cubes could be the real ones. And at times there are equations that are written out 2 different ways. So for a lot of these are multiplication examples. You've got the repeated addition and then the multiplication that you're able to show. I've got 5 fours, so that's 5 times 4. And you can show the jumps on the number line, and then you can show the total, things like that. So the idea of not only representing and representing broadly, but we want to make those deep, more connected ideas across math representations. So before I go on, I want to pause and just make sure, check in with you all. Does anybody have any questions about this idea of what I mean by when I say representations and or algebraic thinking? You just come off mic. You don't have to raise your hands or anything. Any thoughts? Okay.
As
So, go
I
ahead,
guess
please.
so I also, because I've perhaps been an intervention specialist for a very long time, my kids really enjoy having rewards. And so we can tie our manipulatives into rewards. And it doesn't just have to be candy or
Okay.
treats.
Okay.
It can be things like extra recess time or 5 minutes break at the end of the bell. And so we can add some sort of incentive, if you will, to encourage them to really examine the manipulatives and how they work. And once they get it and they understand it, then I like to provide maybe a little red token, maybe for their first try. And they get a series of tokens. And once they get 3 tokens in my math class, then they get 10 minutes free time at the end of the period, or 5 minutes free time. Or I do indulge them in some dum dum suckers and some other food type treats, because I don't lose sight of the fact that these primarily high school freshmen and sophomores still have an affinity for food, and especially treats. So um, I try to make math more fun and rewarding that way.
Mhm.
And even if it's just a little bit at the beginning, a lot of kids have never associated fun and enjoyment with math. It's always been something that's hard. And so I try to approach the whole subject in a little different way. I try to let them see that there are benefits of little knowledge. And if it's just little knowledge of manipulatives, that can set the cornerstone for the rest of their development. And so I try to kind of take the edge off math, so it's a little bit more friendly and a little bit more fun. So that's all.
Yeah. I'm hearing a couple of things in there. It sounds like you're really trying to get them to engage with the process of math. Um, and like they don't have to know the whole thing, but I want you to try. And if it takes a little incentive to get them to try, and then once they get in there, they realize, oh, I can do it, then it's like the scales tilt your way.
You can really tell if you have success when the kids forget about the reward at all. And they're so enamored by the fact that they got things correct that they
Yeah,
just want to keep going. And
yeah,
that's when you really get that aha moment. You're like,
yeah,
man, these kids are getting it. They're not
yeah.
even concerned about what the treat is anymore.
And if they don't remind you, you will forget too, right? Anybody else before I go on? Okay. Well, I kind of built the next segment around a few tips, and I'm hopeful that I've created them. You guys are representing a pretty wide variety of student grade levels, but I think, that it's not tied to specific math, but it's tied to how we are using the representations in ways that can benefit the students in multiple ways. So I'm going to just share the first tip. Obviously, we want to use manipulatives. Different students will have different needs considering sensory issues. So some people are going to like it louder, some people are going to like it quieter, some people are going to like certain types of manipulatives. But I do want to, reiterate what I feel like all of you are already saying, which is, we need to use the manipulatives because they're helpful for helping students to actually understand the math. And also, when we combine it with other representations, we're actually helping them to make those connections. If they do have some sensitivities, we can seek out some of those quieter manipulatives, as you see there. There's plenty that are out there on the internet. And that could be a critical point for students that, have distinct noise level needs. So at this time, I'm going to give you a link in the chat. We're going to, let's see, where's that address? This is to a Google document. And I'm going to give you a second to click on that and just get it opened up. Take a peek at it. You'll see the same first page that we had in the slideshow. I'm seeing little icons in there. Is there anybody having trouble with the link? Okay. And I have done a lot of color coding today, so you'll see at the top there's a bunch of the same page over and over again. So each one of you can hop onto a different page and write your name in the name spot and claim that one. And then we'll go over the directions. We'll just do a little quick activity. Okay, let's see, Sydney and Rebecca. And here I have found a spot. Any of those yellow ones are all exactly the same. And if you click on the box with your name, you can write your name, and then there's a box below where you can jot things. And then to the right are a bunch of what I'm representing to be digitally colored tiles. And those are able to be moved. So just try and pull those around a little bit and see what happens. They should, I think, stay the same size. It'll just let you move them around. Okay. Now with our students, we would want to do this with real materials, but not being in person makes that a little bit harder. So we've got a problem that's on the screen, and I'm going to have you go ahead and solve that on your digital paper. And it says that Jaden is building a garden with his granddad. It will be a rectangle. The garden will be 7 feet wide on one side, and they need the area of the garden. Oh, I have a typo there, don't they? They need the area of the garden to be 21 square feet. How wide should they make the other side of the garden? And then to the right, you'll see I've got some teacher's notes. So you're imagining yourself as the teacher. You've already been practicing making area models with blocks with your students, which are the little color tiles. And they've been using the area of a rectangle. Um, and they know that that is equal to the number of squares that would cover the rectangle exactly. And then in the past, you've given them the length of both sides and asked them to find the area, but today you've changed the problem a little bit. So your task is to go through the little steps there. I've already read it out loud, but I would, think of in my mind, how would I introduce this to my students, particularly if I have students that struggle with reading? How many times will I read it? How will I pull it apart? How will you make sure that they know what they're trying to figure out? And then you're going to use the blocks on your page to figure out the answer to the question and then do a double check and think about how will you know if it's correct and think about how your students would answer that question. And then I'd like you to write a multiplication equation, a division equation, and then the answer to the question. So you just take a couple minutes and complete that on your screen and kind of think it through. And, if anybody has any questions, feel free to throw those out there. think we'll go ahead and move on from here. Is there anybody who would be willing to talk through their what they did on their sheet and just explain how you would would want the students to solve the problem? Are you willing to volunteer?
I can do mine.
Thank you.
So I was trying to think as a kid while I did it and not have known this off of the top of my head. And I just started with 7 across the top, and then instead of just doing 3 right away, I did another 7 and then counted it, and then did another 7 and counted it until I got to 21.
Okay.
And then I just did 7 times 3 is 21, or 3 times 7 is 21, and then 21 divided by 7 is 3, or 21 divided by 3 is 7. And then we figure out that the other side needs to be 3 feet for it to be 21 for the area.
Great. That's what we would want our students to do, right? We would like to see them to be able to successfully, take those 21 and organize them correctly. And obviously this is not, a middle school, appropriate level problem, but as some of you have noticed or mentioned earlier, sometimes the grade level that they're in doesn't necessarily mean that's where they are for a particular topic in math. And so this could be appropriate even for a 6th grader or a 7th grader, an 8th grader. Go back and revisit it. So the other question I'm wondering, several questions. So as we are thinking about our students, particularly students with autism, what would make a problem like this difficult for your students? And as we're thinking about difficulties, our job is to think about how we can break down those barriers. So what could we do to make it more accessible for them? Thinking about your students' needs, what other needs besides math needs might we be able to address with this type of problem?
I think one of the things, just thinking about my students right away, that would be difficult is that it's worded differently, is that it's like kind of telling you the answer and asking you to figure out that other part of the question. Where I think right away, again, when I was saying my kids would shut down, they'd be like, well, this is different than what we usually do.
And how do you have any ideas about how you might address that potential for shutdown?
I think just thinking through it, like a lot of times I'll kind of just be like, well, you already know the answer, like that makes it easier.
Okay.
Like trying to like put that in their head instead of having it seem harder and just being like, oh, well, like they already told us the answer, now we just have to find the other part of the problem.
Right. So you already know how many pieces to take out. You have exactly 21. You can't take any more out of the bank. So you get 21 pieces and now you can start playing with them until it works out. Good. Anybody else?
I have something. When I look at the students I'm working with, a lot of times we deal with arrays. And that's why I have the arrows, because even today we were talking about which way do columns and rows go.
Right.
And so that's why I didn't even get the problem fully completed, because I knew for my kiddos, I'd have to put in that visual of which way do the columns go, which way do the rows go to build an array.
Mm-hmm. Let's see. You're, I want to make sure I've got the right one up. Is that Kira?
Yes.
Okay. Okay. And do you feel like that is a common misconception when students go to do arrays? They're immediately doing just a length and just a width, and they're not filling it in like a full rectangle. I feel like that's something I used to see with at least my 3rd graders. So
I agree.
I could imagine that structure, what you're doing, is very helpful because we know that our students with autism really like a structured environment. And so knowing every single time that they're doing an area type problem or an array type problem, they're going to have the two sides and they're going to be exactly the same because they're a rectangle. So I think, being intentional about having the labels at the top and the side makes a lot of sense. Anybody else?
I think also another thing that like I have my students do is when they finish it, like how Kira has those labeled, like I didn't do that, but I would have had my students label the sides 3 and 7 and then even right in the middle 21 so they could grasp that concept of why this is how you could solve it.
Mm-hmm. Mm-hmm. And I definitely noticed when I was teaching third grades in particular, I taught that the longest, but how you do it is how they want to do it. So when they see that being modeled, they just want to do it the same over and over again. And so I think leaning into the fact that students really like to have that, doing it the same each time is probably helpful. Um,
Can I touch a little bit on that and what you just said? I know what some of my students with autism are struggling with.
mhm,
I'm sorry, there's a feedback. I don't know why.
mhm. Do you have two devices
I
on?
don't know how. If you want to kick me out of one of them.
I'll see if I can. I'll figure it out. Go ahead.
But what I noticed is the curriculum that our district uses for elementary
Hmm.
wants them to learn several ways to do everything. And so sometimes my students with autism struggle with, yes, I know you know how to do it this way, but now we're asking you to do it a different way. And so it becomes a hard battle for them to understand that there are multiple ways to do the same type of math, and it's part of the curriculum, and they can have the right answer, but
Hmm.
it's not how they were asked to do it, if that makes
Hmm.
sense.
Hmm. Oh yeah. And I feel like that's been sort of I feel like that's been newer since the Common Core came
Okay.
in. And that has been a struggle for some people because some folks are kind of the mindset that there's lots of ways to do it and accept that the students can do any of those ways, but really letting them choose the way they want to do it. That's one perspective. And then other people say, no, you have to try it all the ways and make some connections across them. And I can kind of see benefits to that because you want to be able to understand how other people are solving things too. But especially for students who are struggling to get the one way, that's an uphill battle, isn't it? I feel like that might be one of those things where we say, okay, well, maybe show them a couple of ways and not make it 6 ways. Somehow be in the middle on that one. But yeah, I definitely feel you on that one.
I'd like to add that when you give kids on the autism spectrum um, multiple solutions to something, that's more of a problem that you're creating. I think you really have to have that one solid manipulative where they can see it, feel it, touch it, and put it into place where they really actually can grasp that concept. I
Hmm.
think after they have a solid understanding of what it looks like, I think that you could go on then and compare your next method. I don't know that you introduce them solely as individuals. I think that you compare, let's look at how we did this manipulation with how this manipulation works. But that again is after a lot of practice on really one solid way to do it. And it's been my experience over the last 20 years that once a student knows one way to get the correct answer, that's what they're ready to do. They're ready to solve and find the correct answer. And then so long as it's correct, you also get the feedback that says, well, I got it right. Why do you want me to do it more? And so, showing at least one, I agree with Dr. Foote. I think showing that one more alternative and really making a compare and contrast, I think that's really a great, that would be a monumental celebration for our kids on the spectrum. But I would never ever show my kids 6 ways to do something because that's just going to create chaos. That's just my
Yeah.
experience.
Well, and I think the thing is, how far can you push back on the curriculum? And, it sounds like, really letting things not be shifting sand underneath the students is important, right? Let them get solid on it. This such great conversation, but I kind of want to just revisit these types of questions with each of the tips. So I'm going to go ahead and press on, but definitely feel free to, come back to any ideas that come up to you as we move on through. But in the interest of trying to get through the 3 tips, let's just go ahead and press in if I can get my mouse to work here. Well, shoot. My second tip is how can I include movement in math? As soon as my computer stops giving me my blue swirling circle, I'll move it forward, but I'll go ahead and start talking about the next thing. So how can I include movement in math? A lot of what I was reading about students with autism is they may need more breaks. They may need more movement. A large percentage of students that were studied actually had ADD or ADHD, so that provides, really seeks more movement in math. So I'm wondering, do any of you already use any type of movement in math?
I do a lot of stuff in my class with dice where they have to get up and roll the dice.
Okay. Do you use special dice, like larger dice? It sounds like getting up.
Yeah, I have these like big foam dice, and you can take the pieces of paper out of them and write on them. So sometimes I'll even do it for like word problems. I'll write certain things on there to like create different word problems, or it'll just be numbers.
Okay. So getting up to sort of roll dice, almost like you'd see in a game show. I love it. Go ahead.
One thing that while we're talking about rows and columns, we do line dancing.
Okay. Tell us more.
And so we go into the hallway and we follow the rows and the columns on the tiles, and we do line dancing until we get it. We play a game where I see if I can get them out, where it's, rows, columns, and I try really hard to go fast and see if I can get them out. And then right now, the favorite game is cup stacking equations. And so they have to roll a die, and for every equation that they solve, they get a plastic cup. And so they're stacking cups. And then, of course, they get to decide how, if they get all 10 and stack their tower, how they're going to knock it down at the end. And so
Well, that sounds fun.
that's a big movement piece because all of them seem to karate chop.
Right.
And so it's a ton of noise, but they've solved 10 math equations without complaining.
Okay. And getting them to persevere because they're playing a game may be easier, right? We've been talking a lot about kids shutting down. They can shut down because they think they can't do the math, but they can also shut down just because they are sick of being in school for a while too, right? So it's almost like they're not even in school in that, game time, right?
I will say, when I go and support in the third grade classroom, one of the teachers they're learning their times tables right now. And so one of the teachers has a jump up challenge going on. And since we've been in indoor recess for like a month now, they have, as part of the recess time, we have a jump rope and they can obviously jump the rope and say their multiplication facts. I think they just do the product for whatever they choose whichever one they want to do and just
So it's like they're skip counting.
they're just like essentially skip counting.
Okay.
And then they get a sticker and think they get some reward. I don't fully know what is all involved because I'm not in there a ton. Um, but unfortunately, I don't have the space to do a whole lot of movement within when I pull my students. The most is I give them the option to like stand at the I have little whiteboards on my walls, and I'm like, okay, so you can stand up and write and use wobble stools, and that's about it. That's about all I
Okay.
have space for. So
Space is yeah, right. I feel like, it's easy to think about how to get math movement in for the younger grades because we do have recess, we do have maybe a little bit bigger classrooms and smaller bodies. Are there any ideas that, really you can think of for, some of those middle school grades or high school grades, even if you don't teach those grades?
We used to, I have only rotated, I mean, in life of an intervention specialist, 1 minute you're in high school, next minute you're, back to your ABCs in elementary. So I just left the world of middle school and about 2 years ago. And one of the favorite games that we would do was a math relay. And they would stand in teams on one side of the room and they would have to, you'd put like multiplication facts, whatever you're going to do, almost in a clock. And they would have to go around and solve. And every time they do one, then their partner would come and running back and forth and tiring them out. They were cheering each other on. The pressure would come off. They would talk about in line. And I'm like, well, if you whisper loud enough for the other team to hear, then they're going to get your answers, but you can talk through it.
Yeah.
And they would begin to strategize who had strengths and knew that they could go last. It was really interesting how on teams doing those sort of team math activities for my older kids was more valuable than individualized games because if they struggled, they like to have a partner that, if it was word problems, if we were doing a rotation around the room and word problems were up, having them with partners seemed to be very helpful.
Yeah. 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 Helping, the strengths of, maybe one's better at reading, one's better at the actual creativity or the math. Yeah, for sure. Rachel, I think my screen is back. Do you want to share? I'm not sure. I can't see both screens now. Yes, you got it up. All right, so go ahead and go forward. I've got a few ideas. I do have, if you want to do this on the Google Sheets, there are green sheets. You can choose one and do it. This is a pretty quick and easy problem. It's Camille is working in the cafeteria unpacking boxes, and she ordered 2 boxes of apples. Each box has an equal amount because each box has an A on it. When we do problems where there's an A and another A, they have to have the same amount in them. So if Camille received 18 apples, how many apples must have been in each box? So we are solving the problem. 2 A's or 2 boxes that are called A have a total of 18 apples. So you can, as you're, working on that, you can kind of imagine instead of having the students just do this with little manipulatives, you could actually bring in apples, you could bring in boxes, you could actually, I know I used to do something similar at Easter time. I would bring in the little Easter eggs and some jelly beans, and they had to put the same amount in each of the different colored, in each of the eggs that were the same color. So you can imagine acting out problems. So I can see that some of you are on the Google and you're taking your apples and you've got, figured out how to get 18 of them, and then you're dividing them up evenly. And you could even, obviously do this with 2A, 3A, 4A. You can vary the amount of boxes over time and give them lots of repetition and practice. So you get that kinesthetic, you can, have those small and large motor skills you're hitting. You're still working with word problems, but supporting them and seeing the boxes, the apples, and also you've given them the equation. Just quickly going through the other examples that I have for tip 2 as we're approaching the end here. The next one is an example where the students can take a sheet and they can color in a particular number. I've got sheets like that made up for you that I'll be sending to you after today, but I've got some that are from about, I think, 1 to 20, and then 1 to 50, 1 to 100, and then 1 to 1,000. But you can create number lines and have the students color in what their number is and then locate where it goes and put it up on, a very life-size number line. It could be up on the wall or even on the floor if it's very long, and have the students move around and show things on a number line. Go ahead and move on there. As you're moving from those number lines that are going in just 2 directions, we can then go into the planar types of coordinate grids. And so we can put one of those on the floor. I've done those in the past with painter's tape. This one looks like it's a model that somebody put on a heavy piece of cloth. I do love to do color coordinating, so kind of like what Kira was talking about with the rows and columns, kids can get those mixed up. So I typically will go ahead and put the coordinate pairs in 2 different colors and then have the x-axis and the y-axis match that to help them. They could actually go over and stand on the particular spot. They can each have an object and put it on the spot, but I would have my students actually go around the outside of that. And of course, as you're getting up into algebra and you're working on linear functions, you can start to map out the ones that you've calculated for yourself in a similar way to see if it creates a line. And then but slide 25 there is very similar to what we were talking about with the jumping rope. I had a partner teacher that was an intervention specialist for almost 40 years, and she had a mini trampoline in her classroom, and she had the display on her wall, and they would sit there and count through whatever fact they were working on. And so adding in donuts always makes it better when you're going to exercise. So those were a few ideas that I had in mind and that have been mentioned in the ALLOhio in terms of making sure we get movement in. But you can see how, we can really expand the idea of representations by including that tactile and kinesthetic experience for the students, especially if they're kind of anxious already about math. It might be good to burn off some of that anxiety. And then our third tip is just really to focus in on talking in math. We've got students who have communication needs. There may be students who really are unable to communicate using their vocal cords, but they may be able to do quite a nice job in writing or using alternative approaches. So if you go on to that next slide, just as I think about having had teenagers myself, when you are in the car with them, that's when you have the best conversations. And I feel like just because we're both looking out the window instead of looking at each other, we start to not be as aware that other people are looking at us. So if you are having students that have communication difficulties, mostly because they don't want to be looked at and it's embarrassing, having things in front of you like manipulatives and drawings, and they're trying to explain why they did a certain thing or how they did a certain thing, can lower the pressure, because Now they're not looking at their audience, and their audience is actually looking at what they did and not their face. So that can be something that would be helpful. You can have students invite friends to math group. So if you are taking a small group and you've got 3 or 4 students, and the teacher says, yeah, sure, you can take an extra student, and they can take turns inviting a friend, and maybe they'll have an extra person in that small group. You can help to broaden that peer group. And, while they may talk differently with their group than they do with their friend, that might be something that helps them to be more, I guess, willing to share. And, the idea that we're really still thinking about those different ways that we can use pictures, numbers, words, devices, computers, any different representation to have the students engage with the math. We're also tapping into how can we help them to verbalize their thoughts, because that can be something that's difficult. So sometimes we can have them speak, and then we can capture their ideas by scribing for them on an anchor chart. So there were a couple of ideas that I had, and if you go on to that next slide there, Rachel, I've got a few mats. In my experience, though, this is younger kids, and this may not be as true for the older ones, but they like to have a defined space. So having a work mat when they go to do their concrete tools, and then translating that into a drawing. Sometimes just going from the real object to the drawing can be a big translation. So supporting the students and going from the work to the drawing to the equation, and then actually answering the question. Just having a simple structure like this, because they know they have to fill in each box, may be helpful for students that kind of skip through. I purposely put about 5 questions on that first question earlier. So using things like this can help to have the students translate across different representations and have them not forget, what they need to do. And then there's another one that's a little bit more advanced. This might be more appropriate as you're getting up into the um, fourth, fifth, sixth, seventh grade. You can fill in any box. I love an activity where you can take and run a bunch of them off on the Xerox machine, and then you just fill in one of the boxes with something. So you could give them the word problem, or you could give them a drawing, and then they have to write the word problem and the equation and the explanation. But you can just quickly fill in any one box, and they have to do the other ones and do that translation. And those items will actually be provided for you too in the link that we'll be sending, or the page that we'll be sending you with all the links. So as we come, full circle today, I'm wondering, I guess at this particular moment in time, what are you thinking about the possibility of using high quality math and teaching and learning, especially representations, for our students, not only in math, but for some of their other goals? Any final thoughts?
One of the things I'd like to mention in terms of math and say, for instance, feet, a lot of my students in a high school advocate for a walk or a break. And if we were to maybe put some painter's tape down in the hallway,
Yeah.
we might have a brand new way of measuring distance as they walk. And maybe they measure enough distance to, then turn it into physical fitness where we're walking our steps. Are we getting our steps in?
Yeah.
And so steps might be like a whole new concept for the school, for high school or whatever. And the kids could also turn that into like a gym requirement or whatever, that they're getting their steps in. I think that when you present, something different, and they're like, why are all these blue stripes on the floor? I just think they're naturally curious. They're going to want to know. And then you just have fun with it. But I was just thinking how fun math tape or painter's tape would be on the hallway floor. That's all.
Absolutely. And, anything that they're actually really interested in. So if the kids are interested in how many steps they can get in a day and competing with one another, boy, that would really work, wouldn't it? I don't want to keep you all after the 5:15 time here, and I'm already there. So I just wanted to mention that we have resources. We'll be emailing this list to you. But on the next slide, I wanted to give you a quick preview. These are the math modules that we have in the ALLOhio website. Everything there is free. And when we send you the link for that, we'll give you some directions about how to create an account. The account is free. All of the modules are free. There's math, there's science, there's UDL. What am I missing? Uh, not ESL. There is a lot of English language arts. We've got some things that have been actually vetted for multilingual learners and for some of the dyslexia. So we've got a lot of really great resources, and every single one of those is free. So we'll send the link and the directions for that to you. And then the second slide there is some of the resources I used today. I know we didn't get to that last set of slides in Google, but you're welcome to look at those. But I'll be sending you a link to a Google spreadsheet workbook that has the things that I created for tonight's presentation. So I've got the number lines and how to create the place value and all that type of stuff. And then on that last page, I've got some websites that I went through and I was looking at, and I gave you some details about what types of things that are there. But I know that a lot of students love to use the computer, and so if we can actually have them practicing skills that we need them to get good at, and in a way that they like. That's another type of representation. It's not even really even on that list, but that idea of interface in a digital way is sort of in between concrete and pictorial because you can move it, but it's still 2D. So all of those resources we're going to email to you so that you can look at those at your leisure. But I just wanted to thank you all for your attention and all of your great conversation tonight. It's been a delight to have time with you, and I hope you're looking forward to the one that's coming up here in 2 weeks. And I'll see you then. I'm going to have Rachel wrap us up here.
Yeah, that truly phenomenal. And thank you so much, everyone, for participating and sharing your own stories and feedback. It really is incredible to hear what you guys are doing in the classroom. Before we go, if you could please take a moment to complete our survey. It just helps to make sure that all of our professional development opportunities are of the highest quality, are relevant, and are useful to what you're doing. It should only take a minute or two to complete. There's a QR code on the screen, or I put the link to the survey in the chat. So if you could please just take a moment to complete it, I'd be very thankful.